Hello student, welcome to the wave optics course, and in today's lecture, which is lecture number 36, we are going to discuss about the multi-slit diffraction. So, we have lecture number 36 today. I am going to discuss about the multi-slit diffraction, but before that we need to discuss few things regarding the double slit problem. So, let me draw once again what was the double slit problem. In double slit problem we had these two slits, this is the opaque region, light was coming here and then we want to see the distribution here, and light was coming here as a plane wave like this, and then from these 2 points they diffract, circular wave fronts are generated. And they will interfere here at some point P, any point P, and the intensity distribution for this system at any angle theta is I naught cos a square alpha sin square beta divided by beta square, that we derived, where alpha was k divided by 2 a sin theta, where theta is this angle. If I draw a dotted line from the center to this, so that is the angle we are talking about. This is my theta, which is pi a divided by 2 pi a divided by lambda and sin theta, and beta was k by 2 b sin theta, which is pi b by lambda sin theta. So, these are two definition, by definition these are alpha and beta. So, today we are going to discuss about this missing order, because when we have cos square alpha and sin square beta multiplier, then we have the individual 0 and individual maxima for cos alpha and sin alpha. So, that we need to first calculate that diffraction. So, cos theta, cos alpha is coming due to interference, and sin beta divided by beta square term is coming due to diffraction. So, first we calculate the diffraction maxima for this. So, diffraction maxima, or rather diffraction minima, because we need to calculate the missing order. So, better we write, because diffraction maxima we already calculated and this transcendental equation is required. So, diffraction minima. Diffraction minima one can find when the value of the beta will be equal to k by 2, beta is k by 2 into b sin theta, that is equal to m pi, where m is m is not equal to 0, but 1, 2, 3, 4 etc. Because when beta m is 0, then beta should be 0, and for that particular beta we will get the maxima. So, let me draw here what was the resultant distribution of the intensity, then it will be easy to understand that. So, this envelope that I am drawing here with the dotted line is due to the diffraction. And so on. Inside that we have the distribution of cos, and that is due to interference distribution. So, when we are talking about the diffraction minima, actually we are talking about these points. We are talking about these points here. This is diffraction minima. But when we are talking about interference maxima, next we do. So, the interference maxima. So, let me first find out what is the condition here. So, k is 2 pi by, so this is, so I can write it as pi b divided by lambda sin theta is equal to m pi, where, and then from here we can write that b of sin theta, that is the condition we have, b of sin theta is equal to m of lambda, that is the condition for minima, and m value is simply 1, 2, 3 etc. Okay. So, b sin theta equal to m lambda is the condition for diffraction minima, that is having the minima here in this location, the value of the theta should be this, the value of the theta should be this. Well, then what we do, we will try to find out what is the condition for interference maxima. So, interference maxima will be when cos alpha will have the maximum value, or alpha will have n pi, that is the condition when the cos alpha has the maximum value, rather cos square alpha has the maximum value. So, that value include 0 also. So, n will have 0, 1, plus minus 1, 2, 3. So, I am just putting the plus sign for the time being, minus will also work, that is the other side of the diffraction pattern. So, then this condition leads us to k by 2 a sin theta or pi a divided by lambda sin theta is equal to n pi, or the simple condition is A sin theta will be n lambda. Previous condition was B sin theta was m lambda, now it is a n lambda. So, the condition of the missing order, that means the what is the missing order? The missing order means the minima of the interference, the diffraction pattern, if it coincide with the maximum of the interference pattern, then we should have a minima. So, let me draw here to make these things clear. Suppose this is the dotted line I am first drawing, and the condition suggests that at this point there will be a, this is the point where we have a diffraction minima. At this point we have a diffraction minima. So, diffraction minima means at this point my condition is B sin theta is equal to m lambda. Now, for the same wave we can have an intensity distribution like this, and this intensity distribution suggests that maybe there is a maxima at this point which becomes 0 because of the lowest value, because of the minima of the diffraction pattern. So, interference maxima was supposed to be there, and that is vanished due to this. So, the condition here for the condition here for interference maxima is A sin theta is equal to n lambda, but this is the same sin theta. So, that means n of lambda divided by A, that is my sin theta, and I am calculating everything in the same sin theta or same theta, that is equivalent to m of lambda divided by B, or in other word we have A divided by B is equal to A divided by B is equal to n divided by m. So, that means when we have, for example, when we have A equal to 2B, suppose we have a slit, 2 slits such that this A equal to 2B condition is fulfilled, then n will be equal to A equal to 2B, that is n is equal to 2m. That means, for if that is the case, then n is the maxima, n define the maxima for the interference. So, n 2, 4, 6, these are the maxima order for due to this interference will no longer be there. So, these are the missing order. So, what is A and B? If you forget, then the A was the separation between the 2 slits, that was A, and B was the width of a single slit, that was B. I am talking about the ratio, this ratio. So, that is why when A is equal to 2B, then this condition arises. So, this is the way one can calculate the missing order. Now, let us go forward to understand what happened instead of having one or two slits, we have many slits. So, now the next we start a multi slit, the most general case, a multi slit diffraction. And formally it is called the grating. So, in multi-slit what happened, instead of one slit we have many number of slits, and the first thing that we are going to calculate, the way we calculate for single slit and double slit, is what is the intensity distribution. It should be a lengthy calculation, but very straightforward. Since we have number of slits is large, here the number of slits will be n. So, we will going to do the same integral and we will going to get a sum of this integral n times, and that is why it will be a lengthy calculation, but the formalism is same. So, pictorially if I draw, then this is the multi-slits pattern, and if I draw here the distribution. So, instead of having one slit, here we have many number of slits, 2 for example 3, then 4, and then this side 1, 2, 3, 4. So, this is one slit, this is 2 slit, this is 3 slits, this is 4 slit in one side, and this is 1 slit, 2 slit, 3 slit and 4 slit in other side. So, these are the opaque regions, and these are the opaque regions. These are the opaque regions, and this arrows showing. So, light will go through these slits and they will going to interfere here at some point P. I need to calculate the intensity distribution at this point. So, as I mentioned, it will be a lengthy calculation, but very much doable. So, let us now define the coordinates like we did in the early cases with this. Suppose this is my central. So, and from here to here the separation between two consecutive slits is A, and width of this is B, usual definition. Then if that is the case, then we need to find out what are the coordinates of these points. For example, the first coordinate, it will be straightforward. First coordinate of this point, it is A minus B by 2, like earlier case. What should be the next one? It is A plus B by 2, like double slits. Now, we go further to this level, and it should be A plus B by 2 plus something and plus A, and that is simply 3 A minus B by 2 and so on. So, for and here this one will be 5 A. So, let me draw in this side in a magnified version, then it will be clear. So, I have one slit, maybe I erase this and then I have another, I have another, I have another, okay. Now, suppose this is my central point, so from here to here this is A, and from here to here this is B, true for all the cases. Now, if that is the case, so this the point here, this is A by 2 minus B. So, this is A minus B by 2, that is the first coordinate of the first point. Then I go up to this slit, this one is A plus B by 2. So, I know this coordinate. Now, I need to go here, and this distance is I need to calculate this distance basically. So, from here to here it is A. So, from here to here it is A by 2 and A by 2 minus B. So, that is the distance we have from here to here. So, A by 2 minus B multiplied by 2, that should be the distance. So, that need to be added here, and if I do, we are going to get this 3 B minus B by 2. This will be similarly 3 A minus B, not, I am making a mistake here, 3 A, this is 3 A plus B by 2. This point will be similarly 5 A minus B by 2. This point will be 5 A plus B by 2, and so on. I believe you just follow the geometry and you will readily find out what are the coordinates of this point. So, I am just doing few cases. So, for jth slit, in the upper side, we have the expression of 2j, the coordinate is 2j minus 1 multiplied by A plus B divided by 2. This upper side means I am talking about this and lower is this. So, this is for example, first slit, this is second slit, this is third slit and so on. And for lower side, the coordinate, lower side coordinate, that will be 2 j minus 1 multiplied by a minus b whole divided by 2. Okay. So, we can check that actually by putting j equal to 1, you can see this is a plus b divided by 2. I am talking about this upper of 1 and this is lower of 1 and it is a minus b by 2. Similarly, for second slit, if I put j equal to 2, then it should be 3 a plus b by 2 and it is 3 a minus b by 2. For third slit, it is 5, for fourth slit is 7 and so on. So, I suggest that you please check once by yourself that how these things are calculated. This is in the positive side and this is the negative side. In the negative side, the value will be just related with a negative number. For example, if it is a symmetric, then this is minus of a by 2, minus of a plus a by 2 and so on. So, the problem is we are having now n number of slits, and if I want to calculate what is the total field, the form will be something like this. So, let me just write down the form that E p, that is the field at point P, will be E naught and sum over all the slits, n number of slits. So, I need to put a sum here, sum. J can go from slit 1 to slit n by 2 one side, and lower limit is 2 j minus 1 multiplied by a minus b by 2, and upper limit is 2 j minus 1 a plus b by 2, and then e to the power of I, the same thing, k y sin theta dy. This is the contribution of the dy, and I add all the contribution plus the lowest side also. The lowest side will be under this integral, everything is same except a minus sign. So, minus of 2 j minus 1 a minus b divided by 2, and it should be minus of 2 j minus 1 a plus b divided by 2, and the same integral e to the power of I k y sin theta dy. So, that is the form of the integral we have. We need to solve this, and essentially I can write this as the summation of. So, let me do that. Two contribution, one is E naught and then j equal to 1 to n by 2, positive side and negative side, and then 2 sum. One is I1, which should be a function of j and theta. What is the value I calculate? Then it should be sum over j, and another is the lowest side is I2. It should be also a function of j and theta, and then by calculating I and j we can do the sum. So, today I do not have much time to discuss about or the calculate in detail. In the next class we start from this point and going to calculate that what should be the total field at point P due to n number of slits. So far we have done single slit, the calculation was easy, double slit also the calculation was not that much difficult, but here the number of slits is n. So, that is why I need to do a sum over all the integrals. So, that we are going to do in the next class and show that what should be the final expression, the general expression for n number of slits, or formally it is called the grating, and how the spectra will look like because of this interference and diffraction combination of both two phenomena when are there, then what should be the form of this diffraction pattern. So, with that note I like to conclude here. Thank you very much for your attention. See you in the next class.